Hello, hello, and welcome to Ants Are Everywhere. This is a live show where every week we jump into an unfamiliar code base and unencumbered by any sort of preparation process, we take a look at it and see if we can figure out what makes it tick. Or if we can't figure out what makes it tick, at least find something interesting about it. So today we're taking a look at the Dart SDK. This is, I think, where all of the interesting bits of Dart are implemented. We've already looked at a Dart project, namely Flutter, which I think is more or less the place where most folks who are using Dart are using Dart. This was a fan request, and I'm also in the process of trying out to build a Flutter app as part of the coding project that's also on this channel. So I figured I would dig into the Dart SDK a little bit and try to remind myself of some of the features of Dart that I've heard about but have completely forgotten about. Now, this is the SDK repo. I noticed there's another repo that's like language design. Let's see if we can find it. Design of the Dart language. And one of the top languages here is tech. So they're using some sort of tech, hopefully LaTeX. But this is probably a very useful resource for any of you who are interested in language design, especially if you program in something like Flutter. Then this will be the place to hang out. In fact, I'm going to bookmark it. If you have Wallabag, you might be able to add some of the design docs to Wallabag and listen to them on your commute or while you're mowing the lawn or practicing your karate or whatever you do. But for this thing here, we're not going to look at the design docs. We're going to dig into the code. And I see some stuff in the chat. MSA, hello, welcome. I'm happy you made it this time too. I like the excitement. Okay, so let's dig in. So I also have a couple of things I noted before I started the stream. One is in languages, 84.8% Dart. That's normal expected. Some C++, that's normal expected. Also C, and then some Python, HTML, and Java and stuff. And I didn't feel like I had a great way to put together like an LSP or like tag-based way of exploring a project with a bunch of different languages, especially since I'm not aware of like a easily accessible Dart C tag generator. And I don't think Emacs will easily let me switch LSP implementations. So we've got a couple of things I can try. I'm looking at SourceGraph again, which should have all of this stuff linked. Hopefully, maybe they do, maybe they don't. And I've also got VS Code and Android Studio as backups, but both of them seem to be objecting to this repo for some reason. Okay, so with that said, one thing we should talk about is what we want to get out of looking at this repo. Since this is a project, namely Dart, that I expect I'm going to have to spend, or I get to spend rather than I have to spend, maybe I should say. I'm going to spend some time getting familiar with it. And at some point, I will probably have to dig into some of the details. And for a project like that, what I like to do is the first pass through, just get a lay of the land, kind of do a breadth first search. Whereas in some other projects, like for example, maybe in Postgres, there's a specific bit of the project. And in the case of Postgres, it was the like the query optimizer. But there's sometimes a specific bit that I'd like to drill into or get a little bit of a handle on. In this case, this is going to be a little bit more exploratory. So if you have a favorite Dart feature, we may not even see it. We may see it and kind of just whiz by it. But that's the nature of the beast, I think, for today. So with that said, let me grab, maybe I'll just skip GitHub. I was glad that GitHub told me about the languages, but maybe I'll just switch to SourceGraph as my default here. So I'm guessing that a lot of stuff is in package. A lot of stuff might be in SDK. Tests might be an interesting way to get a handle on things for a complicated project. Often the things that are tested are either one of two things are happening. One is it's important. That's one option. Another option is it broke before and it was subtle. So that's another option. So there might be interesting things here, but my guess is these are going to be not really where I want to enter the code base. Samples would be good for if you wanted to learn Dart, or if you wanted to compare like samples would be good for another sort of poking around, not necessarily the one we're doing. Runtime looks very promising. We have, among other things, the VM. Platform stuff, which is probably pretty heinous, but important. And lib and include. Let's definitely open VM. Maybe lib. And what's in bin? Let's just see what's in bin. We've got a bunch of C. Bin might be important, I guess. And let's see what's in package. We have analyzers. What are we analyzing? Error, exception, some file system stuff. Analyzers might be important. I'm not sure. Let's do a search. But I don't know if this is like static analysis or if this is like part of the an integral part of like the some sort of like the just-in-time compiler or the compiler or whatever. The Dart analyze command tool to analyze their Dart code. Okay. You may want the Dart analysis server. So this looks like it's probably static analysis, so I probably don't need it, but we'll see what else is in package. We have Dart to JS, info, native, WebAssembly, maybe native. Let's look at. I don't really know what Dart dev is. I guess I'll ignore it. I'm not sure about DDS, front end and front end server. Let's just open a few of these at, oops. I meant to open JS. The kernel is probably important. mmap, meta, this is looking like it's pretty low level, except linter is not so low level. Scrape, I guess we'll open scrape. I don't know if that's like web scraping. Status file, telemetry, test runner, and some more VM stuff. Look at VM service protos. All right. So that's some stuff in package. I'm sure there's other more important stuff in package. Is DAP the debugger? Let's look this up. Dart DAP. Lightweight Directory Access Protocol, LDAP. I don't think this is for LDAP. The DAP specifications along with their generating code. Debug adapter protocol. Yes, I think this is the debug adapter stuff. Build, I'm going to guess, is not so important, although we have a Fuchsia directory for folks who are interested in Fuchsia, but I'm going to ignore it. So we got some stuff from runtime from package. SDK, bin or lib. We should look at Dart. This might be the... I'm curious about WebAssembly, but I don't know anything about WebAssembly, so I don't think I'm going to learn anything about either Dart or WebAssembly from that particular file. But maybe on a next pass, or maybe if we do like a WebAssembly theme week or something at some point, then I can come back and look at it. Under lib, we have things like async, which I guess we might as well look at. Collection is probably like Dart collection, the things like, I think hash maps are in there. Core seems important. FFI should be the foreign function interface, like interfacing with C. I don't know why IndexedDB seems important. Maybe they use it internally for something. What's internal? Things like async cast. Let's look at cast. And internal.dart. Iterable. Linked list. These seem like maybe just like core programming language concepts. In Dart, isolate seems important. I have no idea what mirrors is. Math and SVG should be straightforward, and I mean, it should be obvious what they do. And then we've got some YAML files, which we're going to ignore. And then we have tests, third-party tools, and utils. I don't know what the difference between a tool and a utility is. Hopefully, tools should have some utility, and usually if something has utility, it's really just another synonym for tool. But we'll leave it there. Here's the runtime VM folder. And I'm not sure that I want to start with the folders because these folders are a little bit intimidating to me. But did I open any actual like single files, or is it all folders? Yeah, so maybe let's just start from whatever the first file is, just to kind of get some momentum going with respect to like actually looking at the syntax. This is a bash script. So this entry point SDK bin Dart is a bash script that must be doing Dart setup. And I guess I'm not going to look at it very carefully, but it does things like check whether you're in Darwin, and it sets some like Dart configuration variable, and it's going to exec bin directory Dart with, I guess, whatever was passed in. Is that what this means? Like the array that was passed in or something? With some, I think that's some sort of array syntax. I'm not going to look it up. Maybe if you're a bash head, you can let me know. Okay, here's cast.dart, which I expect to be something about casting in the type sense, like casting one type to another. Casting wrappers for collection classes. We've got an abstract class, which has this underscore thing, which I think is probably like a privacy marker in Dart. Yeah, maybe I can look it up. Dart variables that begin with underscore. It is not just a naming convention. Underscore fields, classes, and methods will only be available in the .dart file where they are defined. So it's the equivalent, maybe in Golang, to starting a variable with a lowercase name. Although in that case, those are available to the whole module or whatever those are called in Go. And this sounds like it's only available in the .dart file. Okay, so we have this cast iterable base. It's just going to provide some base functionality, and it's only available in this file, so it's presumably factored out just for convenience of the people who develop this cast stuff. The following members use the default implementation on the throwing iterator. These are all operations that have no more efficient implementation than visiting every element in order. Okay, so this is like things that are linear in the number of elements in the collection, or that has no more efficient way to get the correct type, toList or toSet. So map, for each, reduce, fold, toList, all of these are common idioms in various programming languages, and these are things that are going to take linear time no matter what you do. Then we have this cast iterator, which implements iterator, and I'm guessing it's going to maybe do some sort of on-the-fly casting. So we're going to create this source variable, and we're going to call cast iterator on the source. I think this might be a constructor, although I don't know what happens with the thing you've constructed. And we're going to look to see whatever move next is doing, which is going to return a Boolean. And we're going to set t get current to source current as t. So this is the cast. So morally speaking, it seems like we're doing what I thought we would be doing, which is we're iterating over the thing that you're casting and like one at a time casting it. But it seems like maybe, I'm not sure exactly what the syntax is doing because I don't know Dart. If you're watching this and you do know Dart, you can tell me. But I think that what it's doing essentially is maybe defining this as a function to be, so that when you call it later, as opposed to doing it eagerly. But just out of curiosity, let me ask ChatGPT if I have it open. They tell me what this code does. I'll add an exclamation point, exclamation mark. So this, okay, yeah, this is what I want here. This method implements the t get current, double right arrow, whatever source current as t, implements the current getter required by the iterator interface. So this is an implementation of the get function, which is what I suspected was going on. I'll ask, is it safe? that, no, I don't want to ask that. I'm not going to ask that. Okay. So that's that. I've seen enough of this cast iterator thing. Let's see what else we got. Here's internal.dart. And what are we even doing? We're in lib/internal. We have no type level, no top level comment, which, in my opinion, we should have, even though it's internal. Maybe they have one internally and they remove it when they publish it to GitHub. We're going to import collection and Dart async. We've got things like, do I get, these are files. Oh, symbols. Yeah. Okay. So, source graph is, I guess, has not fully analyzed these files. That's fine. I can do without that. Okay. So what do we have? We've got this powers of 10 thing, which I guess they've decided they use them often enough that they're just going to keep them. They're going to compute them ahead of time and just use a lookup table. Whatever code unit is, an iterable of the UTF-16 code units of string and index order. You've got external name, which marks a function or library as having an external implementation. Yeah, I have no idea what this parse hex byte future. A bunch of hash stuff. Hash, so hash 7, hash 5, hash 6. These are all taking, like, it looks like the whatever the number is, hash n, it's going to take n ints, and then the final int is going to be a seed. And it's just going to combine them. It's just going to hash them all together. Why? I don't know. I assume this is used for important stuff. And it's a lot of this hash stuff. And stuff about external objects. Whatever a since is. Annotation class marking the version where SDK API was added. A since annotation can be applied to a library declaration. Okay. And we've got some things that kind of look like error codes. Internal server error is 500. Okay, so these are the this is like the HTML or rather HTTP error codes. Not implemented, bad gateway. So things like constants seems to be up in here. Yeah, HTTP status. Okay, whatever. So that's actually somewhat interesting. But until I have like a better sense of the language as a whole, I want to keep moving along a little bit quickly. So here's iterable. I'm guessing this is going to be the basic iterable like class. Marker interface for iterable subclasses that have an efficient length implementation. So it's going to have this length getter, returns the number of elements of the iterable. This is an efficient operation that doesn't require iterating through the elements. So I guess this is things like when you have some list, you might store the length of the list along with the, as a separate variable internally. Or maybe if you have some sort of map, maybe as you add elements and remove elements, you also increment and decrement length and that sort of thing. We can hide the efficient length iterable, and we can do a bunch of other things. So here's efficient length iterable. List iterable of E. That's like a templated list iterable. It's going to extend efficient length iterable, so I guess you can efficiently get the length. And it's going to implement this hiding thing. I'm not sure why you want to hide it. Also implement, so it's impossible for the upper bound algorithm to get efficient length iterable as the result. And so what are we going to do? We're going to, I don't know what this statement does. Int get length. I guess it's declaring something. Doesn't seem to be doing any operations. Oh, this is an abstract class. So maybe the syntax means these are the things you have to implement. I don't know. But that's going to be my theory. And there's a bunch of implementations like of any. Okay. That's iterable. That's actually somewhat interesting. I bet if we looked at that carefully, we could have a really good sense of how that works. But I want to get more of a sense of the structure of the language. So let's try Do I still have, I think I don't have Android Studio open, but I do have VS Code. Everything is red. I'm not sure why everything is red, but let's look in compiler. Source, common, constants. How about compiler.dart? Okay. So this is long. Do I get to jump to things? If I can't jump to things, I'm just going to, can I go to implementation? No. I can find references, which I think is just doing a search. Go to references, nothing. You're useless. VS Code. All right, back to here. All right, here's isolate, SDK lib isolate. We've got compatibility. Sorry, not compatibility, capability. Isolate and isolate sources. And let's look at isolate. An isolated execution context. And now that I'm thinking about it, if I'm going to not have any great options, I might as well use Emacs. Do I have a Dart mode? Bear with me. Okay, here's isolate. And we've got some classes. This seems to be like a big common and isolated Dart execution environment. All Dart code runs in an isolate, and code can access classes and values only from the same isolate. So isolate is, it's a unit of isolation. I think it's a little bit modeled on the JavaScript isolates in V8. And we did an episode, I think, on what is it, Node, and we'll probably look at V8 at some point soon. I can't find a good. Here's okay. So this seems to be some sort of loop. There's some sort of event loop, I think, in an isolate. Presumably, it runs on one core, and then if you want parallelism, you can have multiple isolates. At least that's my vague understanding. Hopefully, all of those things are mostly true. But this is going to tell us more. Not here. An isolate object is a reference to an isolate, usually different from the current isolate. So I guess it's like other. It's like some other isolate. It represents and can be used to control the other isolates. I don't know if that means all isolates can control all others, or if there's some sort of hierarchy of control. When spawning a new isolate, blah, 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 isolates run code in its own event loop. Okay, there we go. And each event may run smaller tasks in a nested micro-task queue. So there's some, sounds like asynchronicity among the tasks. You can have like a task queue, if I'm understanding correctly, but there's like a event loop that's, I guess, bigger in some sense. That's and the micro task queue is for like stuff that's going on within the context of the isolate. An isolate object allows other isolates to control the event loop of the isolate it represents, and to inspect the isolate, for example, by pausing the isolate or by getting events where there's an uncalled error. Cool. Okay, and so this is really a class for representing the isolate. So I'm not expecting to see here the like nitty gritty of what actually goes into implementing an isolate. But we have immediate argument to ping and kill, ask for immediate action. Okay. We have before next event. I guess when you call ping or you call kill, which I'm guessing are methods, you can say whether you want it to be immediate, whether it can be before the next event, and so forth. We have a send port, which is a control port used to send control messages to the isolate. The control port identifies the isolate. I don't know if that means it's a port in the Unixy sense, or maybe it's just like a number that serves as a mailbox. We've got some stuff about capabilities. Capability granting the ability to pause the isolate. I would like to know where capability is defined. Maybe it tells us up here. Capability.dart. It's part of capability.dart. Not quite sure what this syntax means, but it sounds like this is like defining a cross-cutting sort of concern. Let's look up what Dart part keyword. Restart Firefox. You're kidding me. All right. I'm not going to remember my tabs. All right. Part of for code generation scenarios recently. What is that Dart? Let's look at this one. Part of is used more and more for code generation scenarios recently instead of deprecated transformers. But what does it do? I'm guessing it does kind of the obvious thing. Dart anatomy. This is about actual darts. And I think DuckDuckGo is just ignoring my search terms. Let's try one more time to get let's try Google. How to use part in Dart. A class method is associated with a particular file, and you want to keep it private only to that file. You want to break your one big file into different parts, but avoid accidentally using any private members of that file in other sections. Okay, so I guess maybe there's some sort of like file locality in Dart that things are supposed to be kind of in one file as opposed to spread out, and part lets you spread out stuff, and there's something about visibility. That's how I'm going to think of it. We've got this isolate spawn exception sort of thing. Let's see if we can look at all of the classes. We've got isolate send port is an abstract interface class, which implements capability. We've got a receive port, which is presumably the dual of the send port. We've got a raw receive port, a remote error, remote runner. I would like to know more about capability. Cool. Let's try again. No, let's try this. Here, let's see if we can do like class capability. In isolate.h. So this is in C++. Oops. So this is runtime/vm/isolate.h. We are now in C++. We're out of Dart land, although we are in namespace Dart. We're going to forward declare a bunch of stuff. This capability, one of the things we're forward declaring. But where's the actual declaration, man? What did I do? I think I searched for class capability. Maybe object.h. Here we go. Corresponds to underscore capability in Dart isolate. So class capability is an instance. It has an ID, an instance size, an ability, I guess, to create a new capability pointer, which you're going to give it an ID and some heap space. And we've got the final heap object implementation. But there's not a lot of behavior to it. So let's see. That's ChatGPT. Hang on. This is my be right back dodge Dart that I that I created just for the certification. Okay, so I'll say, tell me about capabilities in Dart. It refers to a set of features and or abilities provided by a class or object. It's an object-oriented programming language. I think Dart likes to sell itself as a multi, uh, what's it called? Object-oriented, but also functional and maybe some other stuff. And objects in Darts can have various capabilities or properties. These capabilities can include methods, fields, and behaviors that define how objects of a particular class can be used and interacted with. Okay, so is method a capability? Methods are functions associated with a class or object. Yeah. Fields, getters and setters, constructors. Is this real? Or has ChatGPT gone mad? So a capability class is an unforgeable object that comes back as equal when passed through other isolates. Sending a capability object to another isolate and getting it back will produce an object that is equal to the original. Okay, there's no other way to create objects equal to a capability object. They can be used as access guards. An isolate can receive requests for operations from other isolates, but only allow them if the request contains the correct capability object. This allows exposing the same interface to multiple clients, but restricting some operations to only those clients that have also been given the corresponding capability. And they can be used inside a single isolate, but they have no advantage over just using object to create a unique object, and has no real security against other code running in the same isolate. So they're these unforgeable object thingies that are used for passing between stuff. And I think we saw when we were creating capabilities, we have this like heap space thing. I'm not sure if that means you pass in the heap space where you know it already exists, but that sounds like this is part of the same. It sounds like this is part of the capability system. I assume this is part of like, what is it, capability-based security? Capability-based security is a concept in the design of secure computing systems. One of the existing security models, a capability, known in some systems as a key, is a communicable, I guess communicable in this sense, the means across the isolates, unforgeable token of authority. It refers to a value that references an object along with an associated set of access rights. Okay, so this is I think that's what this is going on. All right, forging ahead. And Zebu Tenkin. How do I know all the? How do I know all programming languages? I don't. I but after a while, you there are a bunch of concepts when you design a programming language, which I've never done. But people who do design programming languages, they look at the existing programming languages and they're like, "Oh, I want these sorts of features." And it'll be the syntax will kind of look like this thing, and so for the same reasons, there's a lot of like family resemblance among different languages. So you can kind of fake it. You can fake a lot of stuff if you have a sense of other languages, and so that's that's mainly what I'm doing when I'm not super familiar with the language. Okay, so this is object. Object.h is, I guess, pretty fundamental, right? So maybe we should look at, let's see. I can do C tags. I think I'm not going to do it. But we have things like initialize object. What are we passing in? We've got things like a class ID, instance size, whether it contains compressed pointers. I'm assuming pointer compression is an optimization. We've got this initialize object, which is going to take an address, presumably a memory address, and that sort of stuff. So this is like some of the low level stuff. This is probably super fascinating. It probably also relatively closely mimics the what's going on in V8. And I saw I've seen a few technical talks on Dart. Most of them I watched a few years ago and don't have a very good detailed memory of like what was going on. But I was looking at one this morning, and I think what they said is they they wanted to use a bunch of stuff from V8, but they couldn't just simply take V8. So I'm going to guess that a lot of the design in V8 is going to show up in one way or another here. But we'll take a quick look at just what's in the directory. We have bool fields, bit vectors, bit maps, allocations, presumably some custom allocator implementation, a parser. Is this the parser for Dart? And we're in the kernel namespace. That's exciting. The class scope building result. I don't know what that's about. I think this is maybe just for declarations in the namespace. I'm not sure. Okay, at any rate, we have things like field key value trait. Type defs needed for the direct chained hash map template. So we have key value in pair. Key is key of, etc. I'm not sure really what we're doing. This seems to be like it says for hash maps. Direct chained hash map field key value trait field set. Zone growable array. This doesn't really look like a parser yet. Has expression temp var. Make forwarding stub. So maybe this is set covariant parameters. Yeah. I don't know. Let's look at, is there a C file in the same directory? Yeah. We can get we have this parsed function, which I guess is probably the type of a function that's already been parsed, which has a thread and a function. But is there a parse function that actually parses the function? I don't know. We've got this allocate variables for parsed function. And a bunch of, mainly that. Is everything a function? I don't know. So if I do occur, let's say, void, everything seems to be void. Everything is parsed function. Okay. We also have this capability thing. We can pause capability, send port. No, I'm back in isolate. Okay, whatever. All right. So let's go back to VM. We have things like raw object, random, and protos. What protos are we doing? Perfetto and tools. Okay. Let's look at the directory up from VM, which has lib and bin. Let's look in lib. Date. I'm presuming this is just time, right? Native entry, date, time, zone, define native entry. I'm guessing this define native entry is maybe one of the things that's defined in the like the platform folder. So that's going to, one of the things Dart does is compile to a bunch of different environments. So you could do Android and iOS and Mac OS and Linux and Windows. So I'm guessing that platform is really about all of the bits where you need to make a choice that depends on which platform you're in. Stopwatch is presumably some sort of just timer. A URI, why does URI have its own thing here? Okay, so URI is Windows platform. I guess maybe a Windows URI. I don't know if Windows uses URIs internally to refer to things. I'm curious what mirrors are. I don't know. Kind shifts. See if Dart mirrors will return anything. Yeah, there are a lot of there actually are a lot of principles. I think everyone just, it's like music or art or anything else. Everyone has their like influences, and they just all everything's kind of like a remix of the stuff that came before. All right, so Dart mirrors mirrors is reflection. So like dynamic introspection, I think is what's going on. I don't know why that involves any sort of kind shift, but whatever. An observatory, who knows? Hacking.md. These instructions will guide you through the observatory development and testing workflow. Okay, so that's runtime. I still don't feel like I have a sense of like really how like the how things are working, but a little bit of it's a little bit's coming coming into view. Okay, so I'm looking at Dart to native. Is that what I wanted? I think that's what I. Maybe I want Dart to JS. Yeah, let's look at Dart to native. Why not? Got Dart to native. Dart. Maybe let's try that. And the enum. Okay, so the kind is AOT or EXE. So AOT, I think, is probably ahead of time, as opposed to like just-in-time compilation. I don't know how AOT differs from EXE. We can write an appended executable, which will return a future, which seems reasonable. And we can generate an AOT snapshot, giving it a string, maybe some sort of name. I don't know what string is going to be. A kernel file, a snapshot file, a debug file. And it's going to run this thing. It's going to call process run. And like pass in command line arguments on the kernel file. Or no, that take the kernel file. So gen snapshot is like the command to generate a snapshot, I guess. I don't know where the actual implementations of those are. What about generate.dart? Generate native. We're going to do a bunch of monkeying around with the directories and the paths. We're going to figure out whether we are an AOT or an EXE file, I guess. The source without Dart. We're going to look at the source path and replace first .dart with the empty string. I guess we see, maybe at some point there's an intermediate file that's saved with a .dart extension, so that I don't know why, but then we remove it, and then we do some more stuff with the output path, and then generate AOT kernel seems to be the function that's actually doing work. See if we can find it. This might be the implementation here. It's going to take whatever Dart is, some Dart string, a gen kernel, platform dill. Is dill like a expansion of DLL? Source file, whatever. Okay, so process run on gen kernel, and it looks like we're, again, calling some external program. And I don't know what that external program is. Okay. Maybe let's look a little bit in, wait, I was here, right? Okay. Let's look in Dart.js. Runtime tools. Maybe we should look in JS. JS.dart. How about we just do a search for Dart to JS, all the things. Maybe this one, Dart.js.dart. This looks more promising. Okay, so we are in a Dart file. Some stuff about extracting parameters, extracting paths, parse command line. And compile. And compile seems like a long-ish function. It's going to return a future of the compilation result. We've got the stopwatch thing. I think we saw the stopwatch file, and I guess this is one of the things that stopwatch is used for. Presumably for things like optimizing the compiler and whatnot. And we've got some URIs. Everything's a URI. Bazel paths. Although as far as I know, there's no real Dart Bazel support. So whether we want help with, whether we trust type annotations, those sorts of things. And I'm not sure what pass through and ignore option do. You can extract the resolved file URI, set output. It was at the end of compilation. I don't know if I have the mode in Emacs that will show me the closing paren. It seems like a set category, set dump info. A bunch of this stuff. This is like options handling. We've got this parse command line function that'll take handlers. Yeah, okay, so parse command line as in we're going to parse the command line arguments. We can read in some source files. We've got this compilation done function, which will return a compilation result. And has a giant switch statement. All from DIL, modular analysis from, well, I still know what a DIL is. Global inference, compiler main. If argument starts with library spec, do some stuff. Set the URI script to platform script. If script is scheme package, await isolate resolve package URI, libraries JSON is script resolve. I'm going to return compile. And compile, I think, is the function we already looked at. Although without tags, I can't really tell for sure. I'm not sure. Let's find Emacs find matching paren. This is. Oh yeah, I can just call match paren, right? Oh, this is defining match paren. All right, no, I'm not gonna do that. What about finding matching brace? So let's do it for paren. Whatever. Okay. So I'm not really sure what exactly is going on with how that actually compiles. I didn't see a lot of actual stuff going on. Maybe just for fun, let's or rather, instead of fun, I mean completeness. Let's check this in source graph, which I think I lost because Firefox restarted. I'll just search for the word compile. We've got this runtime compiler CC. Maybe it's in the CC stuff. I got to get rid of this, whatever this is. Maybe zoom out so I get more surface. These are command line flags. Irregx compilation pipeline. I don't know what irregx is. Is this a pun irregular expression? Eregex is a portable, efficient, irregular expressions. Supporting POSIX syntax with various irregular PCR extensions. Okay. So maybe irregular expression is some sort of known pun for extended regular expressions. So we seem to be doing real compiling stuff. We are matching some irregular expressions. We're going to build a flow graph with the Dart compilation pipeline. We're going to return a flow graph. Got some stuff with zones. I assume this is like memory zones. Can I really go to definition? Maybe it's analyzed a bit since I initially imported it earlier. Okay, so we've got this VM tag scope, etc. Parse function zone. Okay, this looks like it's really actually doing some compiling. Into what? I don't know. I don't know if this is compiling to just the intermediate representation. Function is optimizable. That's a nice function to have. I wish I could call it on all my functions. I'm guessing this is compiling to intermediate representation. And let me actually open this in Emacs again. We'll just go back and forth until I feel like I have a great setup. All right, so this is compiler CC. What about compiler.h? Again, so we have a compilation pipeline class, Dart compilation pipeline, irregular expression compilation pipeline, compiler, sends whatever all static is. And compile function generates code for a given function without optimization and sets its code field. Returns the raw code object if compilation succeeds. Otherwise, returns an error pointer. Also installs the generated code on the function. So compile function returns an object pointer, which I'm guessing is a pointer to a Dart object. And then we've got this function, compile optimize function, which will presumably optimize. Compile all functions. And then we've got this background compiler. Class to run optimizing. Optimizing is a good word. If you're in an optimization startup, that can be your name. Class to run optimizing compilation in a background thread. Current implementation. One task per isolate. It dies with the owning isolate. So I'm guessing that the background compiler is maybe used for things like just-in-time compilation. We can enqueue compilation. We can visit pointers. And we've got some stuff about background compiler scope, etc., etc. Oh, we're in the JIT folder. So this is all just-in-time compilation. Okay, that's great. That looks real. That looks like some real work is being done. And I'm wondering if all the real work is really just being done in C, which would kind of make sense. And then we have in the VM, which is also where the JIT compiler was, we have the precompiler. And the precompiler, I think, is what ordinary people just call a regular compile. Compiler is just going to compile things ahead of time. But into what? Maybe this will tell me whether it's the intermediate representation. No. Maybe I can just search for the word intermediate representation. Oops, stop that. Intermediate scopes, intermediate value. Intermediate language. Wait, what? It's in the glossary, right? A representation of that's at the level of the resolved AST. Yes, I know that, but where is it's in the kernel. Maybe? Is the kernel where I want to be? Let's try package kernel. How about AST? Lots of AST stuff. Okay. So this seems to be more compilery stuff than we saw before. It's just one thing in the AST folder. It's this patterns thing. And it's part of ... slash dot 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 slash AST dot Dart. So let's look at that up. Dot dot AST dot Dart. Here we go. All right, if you are adding, when changing this file, look at this, look how long this code comment is. So for most of the files, we got no code comment telling us what was going on. And here we get a, what, 64 line comment. I'm wondering if they chose, I mean, I guess ignoring the copyright. I wonder if 64 is meaningful. Okay, so this tells us that this is where the most interesting bits are. So there's stuff about error handling, static versus top level. And this is, I think, for people who are coding, hacking on this particular code. We've got a node starting to look familiar. The node's going to be, I guess, the part of the tree. It's going to have accept and accept one. I don't know if there's R. I'm not sure what R is in this context. But we've got this visitor thing. So we're doing visiting. We're doing nodes. Presumably there's going to be some branching. We can convert things to strings, convert to text. And then a tree node extends node. Okay, and it's got a parent and presumably some children. You can do more visiting. You can visit the children. You can transform the children, which I think every parent has tried to do at some point or other. And we can transport or remove children, which I think is probably something maybe every teacher has tried to do. Replace child, replace with. Okay, so this is tree stuff. This is in Dart. Okay, so we're going to build up an AST in Dart. And then presumably this is the AST is maybe the sort of thing that it hands off to the compiler. Although it seemed like the compiler, like the just-in-time compiler, was compiling like one function at a time. And so maybe it's not getting the AST. But at any rate, we're doing something with the AST. And kind of now that I've found it, we've seen so many of them that maybe we don't need to look at it closely. But at least this, for me at least, this really helps me orient me to like what's actually important, which folders are important in the repo, and where I might need to find things in the future. Here's kernel.dart, which is probably also important. We have URIs and strings and whatnot. Load component from binary. Yeah, write component to binary. We've got loading and writing, write library to text. Yeah, not much here in this part of the kernel. We've got native type checker. Oh, sorry, naive type checker. Let's look at that. It's going to extend type checker. Import type checker.dart. Do we have? There we go. This is going to perform type checking on the kernel IR. Kernel IR is kernels. Kernel IR must be intermediate representation. Although when I searched for intermediate representation, I found nothing. So I'm wondering if I search for IR, am I going to find all of the things? Yeah. So if I had searched for IR instead of intermediate representation, I would have found AST immediately. I would have found the type checker. So that's all cool and all, but just for usability, it might be good to sneak in the word intermediate representation every so often, like the first time it appears in a major file. If I were the Dart, that would be my feedback to the Dart people. Okay. So we've got this abstract class type checker, and it's got some core types. I'm not sure what makes something a core type. Yeah, we're importing class hierarchy and core type. Let me see if I can open up core type here. So the core types, we just give this list of things like object, null, bool, string, all the classics. Record, I think they just recently added relatively recently. I don't know what an invocation is. Maybe it's like a little bit like a lambda. It's a thing that you can invoke. We've got some internal stuff about lazy initialization, reachability, and symbols, and some async stuff like future and stream. These are the core types over on the right here. And this kind of looks to me like if you've ever looked at the generated code of a proto file in like C++ or whatever, it kind of looks like that sort of style. It's just like all of the things in kind of like table format. Is null. I guess this will check whether a type is null. Let's look at is null. If it's invalid, it's not null. Okay. I guess that makes sense. But normally things are like trivially true of, oh no, maybe not invalid things. Okay. If it's a null type, we're going to return true. And then we're going to check the type nullability, type.nullability, and whether it's equal to nullable or legacy. And if so, we're going to, I guess, declare a non-nullable type variable, I think is what this does. And we're going to try to declare it as non-nullable and return is bottom. So is bottom, that should be like where there's some type lattice and bottom is like the like the false or whatever. The definition of bottom, see the following. I will see the following. Here, we are now in the language repo that I talked about at the beginning. So for all the type people out there who are curious to know, I don't know how to pronounce his name, Zabu Dankale was asking about, we were talking about how a lot of programming languages borrow from each other. So one of the things that programming language people study are things like type systems. And so this would be a place to go if you're interested in type systems. But what did I come here for? Bottom? I should spell it correctly. The object bottom is true for types equivalent. This document relies on several type classification helper predicates, which are specified in the null safety specification. Top, which is true for all top types. Object, which is true for types equivalent to object. Bottom, which is true for types equivalent to never. Okay. So here's the isBottom function, and it just has some conditions, and then calls underscore isBottom, the never type. Yeah, so all that looks actually pretty interesting. It looks a little bit different from something like Haskell, I think. This seems a little bit more homegrown, but I'm not positive. So at some point I may do like a type thing and look at a bunch of different type systems, and hopefully I will remember at that point to come back and check the Dart stuff. But at any rate, we have this type checker, which is going to perform type checking. And what is it going to do? We've got this check component, which you're going to pass into some component. And on each component, the thing it does is it's going to iterate over the libraries in the component. So whatever a component is, it has some libraries. And we might ignore the SDK. And then we'll iterate over the classes in the libraries. And we're going to call this function for each override pair that's defined in like some hierarchy file. And okay, so somehow I assume what this thing is doing is finding pairs that can, like, where one might override the other, and then we're going to call check override to I guess verify that the overriding is correct. And then we've got this type checking visitor. So this override thing mainly seems to be about checking that the types define a valid hierarchy. So there's essentially some like tree or lattice or graph that has a parent of or child of relationship, and it seems like it's just verifying that those relationships are correct. It's just essentially walking some sort of graph. Here's we've got this visitor thing, which is a type checking visitor. It's going to take whatever this is, I guess the type checker, the environment, which I still don't know, which I don't know what it is in the technically as part of Dart, and in some hierarchy. Again, iterate over libraries, iterate over classes, iterate over fields, and visit every field of the class, iterate over constructors, visit every constructor of the class, and iterate over procedures. I don't know how in Dart procedures are different from, oh wait, yeah, I guess procedures must just be methods or whatever, functions. And we're going to visit every procedure. And then we're going to set the current type to null after we visited everything and iterate over the procedures again. Oh, I guess this is if we've, what? We've already done all this stuff for the library classes. And now whatever, okay, so these are, okay, I see. So first we look at the classes in the library, and then that's broken down into field constructors and procedures. And then we do the procedures and fields just like we did classes. And we're just going to visit all the procedures in the library. And then we set current library to null. Cool. And we've got these things like getter type, setter type, check, override. I think this is the thing that's called in the hierarchy function, right? Check, override. I claimed that this was essentially just doing inheritance stuff. Let's look at the implementation. Check that own member of host can override super member. So we just look at if is setter. So if it is a setter, I guess, then we can check whether it's assignable. Otherwise, we're going to check, we've got this other check assignable. And check assignable says check that from is a subtype of 2. Yeah. Okay, so subtype means just that there's an arrow from one to the other. I don't know if they have the arrows from the subtype to the supertype or vice versa. Where is an AST node indicating roughly where the check is required. Okay. And then we can do things like check downcast expression. We've got this type checking visitor stuff, which is going to look, I guess, at the nodes and do type checky stuff. Okay, so that's cool. We've got type algebra. Returns all free type variables in type. Substitute returns a type where all occurrences of the given type parameters have been replaced with the corresponding types. Yeah, this looks pretty interesting. All this type stuff. But I'm not going to dig too much deeper. So this is where cool stuff is, package/kernel. Not so surprising that stuff is there. I think this is one of the directories I had originally opened, but so that's not so surprising. Let me see if there's anything else. I kind of want to know where it is. I guess I find the dependency resolution of Dart and Flutter a little bit opaque. I'm wondering if I can find out stuff about the dependencies here. I don't know if that's a separate tool. But maybe I can look for pubget. Is that a thing in Dart as well as Flutter? Analysis server. Maybe dependency. Let's try it with no suffix. I get both dependency and dependencies. This is, I think, a different kind of dependency. Kernel translation helper. What is cha? This is part of the compiler, so I assume it's part of the dependencies in the sense of like, you know, one class depends on another rather than one library depends on another. Maybe I'm not finding anything so fundamental. I'll ask ChatGPT, what is, from a language design perspective, what are the top 3 coolest things about Dart? So we saw a little bit of where the ahead of time and just in time stuff was. We didn't really look closely at it. Strong typing with optional typing. It does type inference, right? I think that's correct. And we saw some of the files where that happens, which would be the type checker, the Flutter framework, which we did in another video. Okay, so tell me the top 10 things, just to see if I'm missing anything that we haven't at least touched on the surface of. So it's going to be consistent with the top 3. I guess that's not entirely surprising. Hot reload. I think there's a Flutter thing. Dart Dev Tools is a suite of debugging and performance analysis tools. That's all fine. We didn't really look at asynchronous programming. That's going to be things like futures. I'm not sure if there's going to be anything really amazing or surprising there. Isolates is cool. I think probably the way that I would learn about isolates is I think I would start with V8 first, personally. So again, since I'm going to be doing Flutter, writing an app in Flutter, I imagine I'm going to be looking at the Dart repo again in the future, or either in one of these videos, or at least just in the process of writing up code, pulling up the code and looking at it. So I think that it probably makes sense to get a feel for the V8 isolates first, because that's where I imagine a lot of the original design came from. Package management, yeah, that's the thing that I find not so great, but I couldn't really find it in the code, so I'm not going to really dig much more than that. Sound null safety, we saw a little bit about the nullable types in the type checking stuff with bottom and all that stuff, and interoperability. I still don't feel like I understand where like JavaScript translation happens. I'm not sure if, I think Dart is producing, okay, so when Dart compiles to JavaScript, so is it producing JavaScript code, or does it produce like VM code for V8? Like, I don't know if it's producing some sort of like VM representation. It produces JavaScript code, not native VM code. Okay. I saw a bunch of things that said Dart to JS. I didn't really get a sense of like how you decide, that this class turns into that class. Maybe that's all straightforward. But I'm trying to keep this at about an hour. I think it would take maybe like another half hour or so to dig into that. So I'm going to leave that for now. I think just going to call it a day here. So thanks for watching. I'll be back next week with some more coding and some more reading.